Hello, and welcome to your technique video for copper amine synthesis and UV-Vis spectroscopic analysis. Let's go through some safety guidelines real quick. As usual, you have to wear your goggles anytime chemicals are out. We are working with concentrated ammonia, which is a base with a pungent odor, so it must stay in the fume hood. Everyone in the room will know if you bring any back to your bench, so don't take it out of the hood. If you spill anything on your skin, make sure to flush it thoroughly with water. At the end of the lab, you can pour all the solutions down the sink to clean up. As always, it is a good idea to wash your hands at the end of the lab. Okay, so now we're ready to get started. You'll be synthesizing a complex ion called copper amine. Your first step will be to weigh out some copper sulfate pentahydrate accurately using the balance. Refer back to the earlier video on using a balance if you don't remember how. We recommend using some weighing paper because it will help you transfer the copper sulfate pentahydrate to the volumetric flask. Fold it from corner to corner like this so that it forms a spout that you can use when pouring it into the flask. Make sure all the crystals make it into the flask. If some crystals don't make it into the volumetric flask, you need to start over. The copper salt can damage the balance, so if you spill any of the crystal onto the lab bench or balance, make sure you clean it up or participation points will be deducted. Next, dissolve the copper sulfate into a small volume of water. You can stir it and warm it with your hand to help it dissolve. Once it dissolves completely, you will have formed this complex ion. Now it is time to move to the hood to add the ammonia. Use a pipette to add drops of ammonia to the flask. Initially, the solution will form the insoluble copper hydroxide, but further addition of ammonia will cause the solution to turn a clear dark blue, which indicates that the copper amine has formed. Add a little extra after it changes color. Usually going up to the middle of this line on the flask is enough. After adding the ammonia, move back to your lab bench. You will be adding water to the flask until the meniscus touches the graduation mark. You must add the water slowly and watch to ensure that the copper hydroxide doesn't reform. If at any time the solution starts to become cloudy, return to the hood and add 5 more drops of ammonia before adding any more water. If you accidentally fill it past the meniscus, you will have to start over. With the meniscus of the solution at the mark, cover with the cap or parafilm if no caps are available, and invert several times to ensure the solution is thoroughly mixed. Once it is finished, pour your solution into a clean, dry beaker and get ready to perform your dilutions now that your stock solution is ready. Unlike the dilution you performed in an earlier lab where you simply took different volumes from a stock solution, a serial dilution is performed by taking a small volume of the stock solution and making your first dilution. Then, instead of drawing from the stock solution for the second dilution, you will use a small volume from the first dilution. This creates a series of solutions that decrease in concentration. We won't go through the dilution technique again in this video, but if you are still unsure about it, you can reference the technique video from the Physical Properties lab. Okay, so now you've made your dilutions and it's time to analyze your samples using the spectrophotometer. This is located down the hall in Chem 360. We first use the spectrophotometer in the chromatography lab, but in that lab we are considering the purity of the sample. In this lab, we will assume that the sample is pure, because we prepared it with the expectation that no side reactions occurred. Thus, the way that we use the spectrophotometer is a little different. We will set the spectrophotometer to a fixed wavelength and measure the absorbance at that wavelength. We are selecting the wavelength for you, 560 nanometers. This wavelength was selected because the sample absorbs light at this wavelength. Your TA will help you to set up the spectrophotometer, but you should be prepared to record both the concentration and the absorbance of each of your samples. Because sometimes a few of the dilutions may look the same, you should come up with a system to label which solution is which without writing anything on the cuvettes. Because we are shooting the light into one side of the cuvette and out through another, you really only need to ensure that the cuvette is clear and clean on the 2 sides that the light goes through. Okay, that's all I have to say for this lab, and I'll see you next week.